Hey guys, welcome again to the Maths Club. If you are just joining us, so welcome. In this video, we're going to be looking at finding area and perimeter of rectangles. If you are just joining us, don't forget to subscribe to our channel, hit the like button, share the channel to a friend. The idea is that we want to help as many people as possible, and we can't do that without you. So without further ado, let's get started. Area is basically the space a shape covers. So if I have a shape like this, so all of this inside here is basically the space it covers. So we're trying to find, given this shape, what space does it cover when we're dealing with area? And area is measured in square units. So go to CY. For 2D shapes, that is shapes that can be defined in the x and y coordinates, we talk about area. But when we're talking about 3D shapes, that means it's not only x and y, but looking at the z, so x axis, y axis, and the z axis, we're going to be looking at total surface area, and we're going to see that in subsequent videos to this. This is a box that contains a grid of squares, and you can see this area here contains 4 different squares. So if I wanted to find the area of this square, I am known that I'm calculating the space this box contains, this box contains, this box contains, this box contains, and that's really just a pictorial representation of what area is about. Rectangles. So what is a rectangle? Basically is a 4-sided shape. Opposite sides are equal in length and all the angles are right angles. The length of a rectangle is always longer than the breadth. I'll say that again. The length of a rectangle is always greater than the breadth. That will guide you in many questions and enjoying the correct diagram. We see an example of what a rectangle symbolizes, and look at this diagram. We're looking at the properties of a rectangle. First one says that it has 4 sides and 4 vertices. So you can see this side 1, side 2, side 3, and side 4. It says opposite sides are equal. You can see this line here, this single line corresponds to this single line. They are opposite each other. That shows you that this line is equal to this line. Like, I'm talking about the length of this line here, AD, is equal to the length of the line BC. Same thing too, you can see this is double and this is also double, showing that they have equal lengths. So the length of line AB is the same as the length of line DC. Third property is that opposite sides are parallel. So you can see this place here, you can see this line. When you see an arrow on a line and an arrow on a line, that shows that those 2 lines are parallel. So this line is parallel to this line, and as you can see this, you can see these 2 arrows here and these 2 arrows here. It just symbolizes that this line is parallel to this line. Fourth is all 4 angles are right angles. You can see at this corner, this is a right angle, this is a right angle, this is a right angle, this is a right angle. Next is saying that diagonals are equal and bisect each other. So you can see this diagonal, this is diagonal, this is diagonal. The points where they meet, they bisect each other. That means that they break it into 4 equal parts. This length is equal to this length. You can see 2, 2. So the length from, if this middle here, if I say this middle here is O, so OB is the same thing as OD, OA is the same thing as OC, and it's also the same thing as BO or OB and OD. This length here, OA, same thing as OD, and this length OB, same thing as OA, same thing as OC. They are all the same. They bisect each other. But look at something. These diagonals, they don't bisect the angles at the corner. If you can see this diagram, you can see if it was bisecting it, you see that the line will have come through the center, but is away from the center, and is very, very, very intentional to show you that the diagonals don't bisect the angles at the corners or the edges. You must take note of that. For a rectangle, the angles at the corner are not bisected by the diagonals. But there's a special case. This is a case where all the sides are equal. In that case, it's no longer a regular rectangle. It is now a special case called a square. So this is a pictorial representation of a square. And in a square, what do you notice? First is that it has 4 sides and 4 vertices, just like a normal rectangle. All sides are equal. Unlike a normal rectangle where opposite sides are equal, but in a square all sides are equal. You can see this is one mark, one mark, meaning that all the sides are equal in length. All 4 angles are right angles, just like a normal rectangle. Opposite sides are parallel, just like a normal rectangle. And diagonals are perpendicular, and they bisect at 90 degrees. So if you look at this guy here, one thing you need to know is that, see this line, before I even move to the perpendicular, see this line, you see that it is at the center, it's at the center, it's at the center, it's at the center, unlike a normal rectangle. So that means that these diagonals, they actually bisect the angles at the edges. They bisect the angle at the edge. I mean that from this I have this 45 degrees and this 45 degrees, 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 and so on and so forth. Also, too, unlike a normal rectangle, these 2 lines here, they are at 90 degrees to each other, so they are orthogonal, or they are perpendicular to each other. In a rectangle, this at the point where these 2 lines meet is not going to be perpendicular for a normal, but because all sides of this rectangle are equal, some things are going to change. So the angles here are all 90 degrees, 90 degrees, 90 degrees, 90 degrees, making a total of 360 degrees, right? But for a normal rectangle, this one could be 30 degrees, this one could be 60 degrees, 40 degrees, this one could be something else. Do you get? But for a square, all these parts here are all 90 degrees, and same thing too, so they also have the same length, just like a normal rectangle. So these are some things, that are some trick questions that can just come, and you'll be swayed if you don't understand these fundamentals. To calculate the area of rectangle, we use the formula length times width. So you can see the length. I told you that the length is always greater than the width in terms of length. So this is the length, this is the width. So the area of rectangle is length times width. While for a square, the area of a square is, since all the sides are equal, it's the same length times width, but this is a times a. Basically, it will give you a squared, or r times r, or c times c will give you c squared, where a, b, or c is the length of a side. Take note of this. If we distribute the perimeter, which is total length of the shape or of the rectangle, if we distribute them equally between length and width, that is, make the sides as close to each other as possible, you would enclose the maximum area. So basically, if I had a square and I have a rectangle, and both of them are of the same perimeter, let's say the perimeter of you maybe you don't understand what perimeter is, but perimeter is just like the total length, this length plus this length plus this length plus this length, right? If I have a normal rectangle and I have another square, both of them have the same perimeter, the area of the square would be far greater than the area of the rectangle. The area of the square would be far greater than the area of the rectangle because of this, which says that when you distribute the perimeter equally, you would enclose the maximum area. So if you want to get the maximum area of a rectangle, right, distribute the perimeter equally between the lengths and the width, basically make it a square. And there is a question ahead that you see all these things apply. So it's more of intuition. If you want to enclose the greatest or the maximum area of a rectangle, make sure that you distribute the perimeter equally between the length and the width, basically make it a square. And then among all rectangles with a fixed perimeter, a square always has the greatest area. I've talked about this, exactly, just buttressing the second point. Among all rectangles, the fixed perimeter, they have the same perimeter, but the area of the square would always be the greatest. Let's see this example. It says that I should find the area of a square whose width is 6 centimeter and length is 10 centimeter. So without doing the fuss about this, we can say the area, we said the area is the length times the what times the width, and that will give us 6 times 10, which will give us 60 centimeter. So this 6 is in centimeter, this one is centimeter, so centimeter and centimeter will give me centimeter squared, and that is why they say that the unit of an area is in square units. Units could be meter, could be centimeter, could be feet, could be anything that symbolizes a length. So this is how you solve a very basic question of the area of a rectangle, and our answer is correct because this is centimeter squared. Great. Example 2 states that the area of a piece of land is 50 centimeters square. Find the value of x if the length and breadth are given as x plus 2 centimeter and x minus 3 centimeter respectively. This is taken from NECO 2002. Let's solve it together. So we're told that the length is x plus 2 centimeter. Remember, the length is always greater than the breadth, and then the breadth is x minus 3 centimeter. So we know that the area is equal to L times B. The area is told to be 50, that is 50 is equal to x minus 3 x plus 2. So let's open up the bracket. That will be 50 is equal to x squared plus 2x minus 3x minus 6. Let's correct like terms. That will be x squared plus 2x minus 3x minus 6. This will come over here to be minus 50 is equal to 0. So that is x squared plus 2x minus 3x will give me minus x. Minus 6 minus 50 will give me minus 56 is equal to 0. So let's take this. This will be minus 56 x squared. What are two values that if I multiplied will give me minus 56 x squared, and if I had will give me minus x? What are the two values? So you could say minus 8x and plus 7x. We've did all of this before. So this is x squared. I'll replace this minus x with minus 8x plus 7x, which is the same thing. So that will be minus 8x plus 7x minus 56 is equal to 0. I'll correct like terms in this first two, correct like terms in this second two. So in this first, what is common? X is common. X squared minus x will give me x. Minus 8x divided by x will give me minus 8. Plus, what is common in these two? 7 is common. 7x divided by 7 will give me x. Minus 56 divided by plus 7 will give me 8. So this is equal to 0. So I have the same thing here, x minus, and I have the same thing here, x minus 8, so I'm good. I'll correct like terms. That will be x plus 7, x minus 8 is equal to 0. I assume that this should not be any problem to anybody. If you have any problem with this, go to the playlist and look for the playlist on quadratic equations. So our solution is x plus 7 is equal to 0, or x minus 8 is equal to 0. So correct like terms, x will be equal to minus 7 centimeter and x will be equal to 8 centimeter, or x is equal to 8 centimeter. Our length can never be negative, right? So x is equal to centimeter. So this is the value of x. The question says that we find the value of x. Great. So therefore x is equal to 8 centimeter. Let's see if we're correct. Great. Example 3 says that the area of a rectangular floor is 13.5 meters square. One side is 1.5 longer than the other. Calculate the dimensions of the floor. This comes from WAEC 1998. If one side is longer, then the other side is the length, because the length is always longer than the width or breadth. You can pause the video and try this out yourself. Welcome back. Let's solve it together. So one side is 1.5 longer than, so if this side is x, this side is x plus 1.5 meters. This is x meters. So the area of a rectangle is the length times the breadth. The area is 13.5. The length is x plus 1.5 and the breadth is x. So let's open up this bracket. That will be 13.5 is equal to x squared plus 1.5x. So let's take like terms. That will be x squared plus 1.5x minus 13.5 is equal to 0. I can solve this like this, or I can multiply through by 2 so that I don't have all these dots. Because what are the two values that I multiply that will give me 13.5? So if I multiply all through by 2, I could say this is 2x squared plus 3x minus 13.5 times 2. That will give you 27 is equal to 0, because 0 times 2 is also 0. So let's take this 2. This is minus 54x squared. So that's two values that when you multiply, they will give you minus 54x squared, and when you add, they will give you plus 3x. Great. That will be plus 9x and minus 6x. Right? So if I replace this 3x with plus 9 and minus 6, that will give me 2x squared plus 9x minus 6x minus 27 is equal to 0. So I'll just correct like them. Just common in this 2. What's common in this is just x. So that will be 2x divided by x will give me 2x. Plus 9 divided by x will give me plus 9. Minus what's common in this 2? Minus is common and 3 is common. Minus 6x divided by minus 3, that will give me 2x. Minus 27 divided by minus 3 will give me plus 9 is equal to 0. So I have the same thing, I have the same thing here. Good to go. Collect like terms, that will be x minus 3, 2x plus 9 is equal to 0. So our answer is x minus 3 is equal to 0, or 2x plus 9 is equal to 0. So x is equal to 3, or 2x is equal to minus 9, and x is equal to minus 9 over 2 meters. These meters, these meters. So we know that x cannot be negative, so our x is 3 meters. But it's also calculate the dimensions of the floor. So we know that the breadth is x, which will be equal to 3 meters, and the length is x plus 1.5, right, which is equal to 3 plus 1.5, which is equal to 4.5 meters. So our length is 4.5 meters and our breadth is 3 meters. Let's see if we're correct. So our length is 4.5 meters and our breadth is 3 meters. Great. Example 4 says that the area of a square field is 110.25 meters square. Find the cost of fencing this round at 75 naira per meter square. This is from 2007. I want you to pause the video and try this for yourself. Welcome back. Let's solve it together. So the area of this square field is 110.25, but the cost of 1 meter square is 75 naira. So we can just say if 1 meter square is costing 75 naira, then how much would 110.25 meters square now cost? So we can cross multiply and see x times 1 is equal to 110.25 multiplied by 75. X times 1 is x. 110.25 multiplied by 7.5, that gave me 8,268.75. So in terms of naira, this is our value. To fence this square field, it will cost you 8,268 naira 0.75 kobo. Let's see if our answer is correct. Correct. Example 5 says that a rectangular playing field is 18 meters wide. It is surrounded by a path 6 meters wide, such that its area is equal to the area of the path. Calculate the length of the field. This is from 2010. I want us to solve this together. Let's assume that this is the playing field. So from here to here is 18 meters. So this 18 meters. Great. Because that is width. Now said it is surrounded by a path 6 meters wide. So this is the path, all of this place here, the outer guy. So from here to here, it's going to be 6 meters. From here to here, it's going to be 6 meters. Also, this width here, from here to here, is going to be 6 meters. This extra place here is going to be 6 meters. And then from here to here is going to be L, the length of this smaller rectangular playing field. So don't mind my rectangle. Rectangles are meant to be curved at all these points, but this is what the tool I'm using is giving me. Don't let a rectangle be curved. Rectangle is straight. So that means that this entire width is 18 plus 6 plus 6. 18 plus 6 is 24. 24 plus 6 is 30. So that means that this entire width here is 30 meters. And this entire width here is L plus 12 meters. L plus 6 plus 6, L plus 12 meters. So the area of the playing field, which will be this guy, that will be L times 18. That is 18L. Let me just say L times 18, which is 18L meters squared. And the area of the sidewalk, right? So for the area of the path of the sidewalk, I can't be able to just say 30 times L plus 12 because the sidewalk is not everything here. The sidewalk is just this place here. So this, like all this place here, and it's just like this place here. So it's just this place this place, and this place. So this is like side 1, side 2, side 3, side 4. So if I find the area of side 1 plus the area of side 2 plus the area of side 3 plus the area of side 4, I'll guess it. But you agree with me that the dimensions of side 1 is not the same as the dimension of side 2, the dimension of side 3 is not the same as the dimension of side 4. So that would be, I could just say 2 times area 1, 2 times area 1 will take care of the area of this place plus the area of this place, plus 2 times area 3. Area 3 will take care of the area of this place and the area of this place. 2 times. Area 1 is, what is this? The length here is L, right? From here to here. Length here is L. And then the width here is 6. So that will be L times 6, which is equal to 6LM squared, right? And then for the A3 is this guy here. This guy here. So let me use this guy. What is the length? The length is 30. 18 plus 6 plus 6 is 30. Times, what is the width? The width of one of this guy is 6. So that's 6. So 30 times 6 would give me 180 meters squared. So I can also substitute and say the area of the side part is 2 times A1 is 6L plus 2 times A2 or A3 is 180. So that will be 12L plus 360. That is the area of the side part. And we're told that the area of the playing field is equal to the area of the side part. So that means the area of the playing field is equal to the area of the side part. Area of playing field is 18L. Area of the side part is 12L plus 360. Right? So let's call it like terms. That will be 18L minus 12L is equal to 360. So 6L is equal to 360, and if I divide both sides by 6, the length is equal to 60 meters. So this is how we solve this kind of questions. You have to be intuitive and know exactly what the question is saying. So you must be able to also break things apart by knowing that this is your first rectangle, this is the second of the one. You can't just say 30 times L plus 12. That won't work because it's not the entire part. This is the third part, and this is the fourth part. Right, surrounding the playing field. Let's see if our answer is correct. 60 meters. Great. Example says that the area of a square is 144 centimeters square. Find the length of its diagonal. Let's take from JAMB 1991. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So these are a square. We know that a square area is a squared length times breadth, because some of them are really the same thing. So whatever is the dimension of this side is the dimension of this side. So our square's area is 144, and if I take the square roots of both sides, positive square roots will give me A to be 12 centimeter. So that means this guy here is 12 centimeter, this guy here is 12 centimeter. So if I draw the diagonal, this guy here is 90 degrees, this guy is 90 degrees, this guy is 90 degrees, this guy is 90 degrees. So let me blow it out. We have this, where this guy here is 90 degrees, this length here is 12, this length here is 12 centimeter, 12 centimeter. So we can find this diagonal, let's call it D. So using Pythagoras theorem, we state that when you're solving a theory question, you have to state it. You say the hypotenuse square is equal to the opposite square plus adjacent squared. Hypotenuse is D, so D squared, opposite is 12 plus 12 squared. So D squared will be equal to 144 plus 144, and that will be 288. So our D squared is equal to 288. And our D will just be square root of 288. Square root of 288 is 16.97 centimeters. So the length of the diagonal is 16.97 centimeter. Let's see if we're correct. So they give us in terms of sod. I want talk about that yet because we've not yet reached there. I don't want to jump the gun. But if I were to jump the gun, let's see what we will have done. So if you look at these 288, we found it from 144 plus 144. That's like saying square root of 2 times 144. And this square root of 2 times 144, I could break it and say this is like saying square root of 2 times square root of 144. We know the square root of 144 to be 12, so that will give us root 2 times 12, which is simply saying 12 root 2 centimeter. So these are all I've solved it. First and first, that's find a perfect square that can multiply something. Most likely is always 2, 3, majorly. Most times, right? 2, 3. Just divide this by 2, then break it apart. You can break up square roots like this, like take the square root of 2 times square root of 144 is allowed, it's permissible in mathematics. And you have it in the short form. So 12 root 2 centimeter. Great. Example 7 states that in the figure, the area of square PQRS is 100 centimeter. So this PQRS, which is the big shape, the full shape. If the ratio of the area of the square TUYS, or TUYS to the area of the square XQVU, so the area of this guy to the area of this guy, is 1 to 16. Find YR. You can pause the video and try this out yourself, but I'm going to go straight into the solution and you see how we're going to solve it step by step. For this question, I'm not going to use any shortcut or anything, but we know that the area of the square is 100 centimeters. So that means that this place here is 10 centimeter and this place here is 10 centimeter. We know that. So I could just say sides of PQRS will just be square root of 100 centimeter, which is 10 centimeter. We know this. It now says that if the ratio of the area TUYS, so if this place is X and this place is X, so the area of TUYS will just be X squared, right? X times X. And if this side is X and this side is X, the number that this place here is 10 minus X, right? Because this place is 10, this side is X, this other side is 10 minus X. This side here too is X, and this side there will be what? 10 minus X, because year to year is 10. We know that. So the area of XQVU is 10 minus X all squared. We know that. We're not told that the ratio, so the area of TUYS all over the area of XQVU, the ratio is 1 over 16. So let's substitute, that will be X squared all over 10 minus X all squared is equal to 1 over 16. Do you know something? That if I have, let's say, 5 over 2 all squared, that's like saying 5 squared all over 2 squared. You know that this is like 25 over 4. You know that. So the same thing, so I could say this is X over 10 minus X all squared. So this guy is squared, this guy is squared. Same thing, 1 is a perfect square, 16 is a perfect square. 1 squared will give me 1, right? And 4 squared will give me 16. So I could say it's like saying 1 over 4 all squared. 1 squared and 4 squared. So if I take square root of both sides, this will leave me with X over 10 minus X is equal to 1 over 4. And I can cross multiply easily. Instead of me trying to open this up, then using quadratic equation, that's a very long step. So cross multiplying, that will be 4x is equal to 1 times 10 minus x will give me 10 minus x. Correct, like so that will be 4x plus x is equal to 10. 4x plus x is 5x is equal to 10. And if I divide both sides by 5, my x is equal to 2. Is that what the question said we should find? No. The question we should find the length, what's YR. YR, so I'll just say length YR, which is 10 minus x, which is equal to 10 minus 2, which is equal to 8 centimeter. So that's how we solve this question. Let's see if we're correct. Great. The The perimeter of a square is the total length of its four sides. So the length of this side 1 plus into side 2, side 3, side 4. That will give you the perimeter. And then perimeter is the total distance around the edge of a shape. So the perimeter of rectangle is the total length of its four sides. So that will be length plus length and width plus width. So you can start with 2 open brackets, length plus width, because you can factor out 2 from the length and from the width. An example. Example 8 states that we should find the area and the perimeter of a square whose length of diagonals is 20 root 2 centimeter. This take it from JAMB 2023. Let's solve it together. So if the length of the diagonal is 20, so that means from here to here is 20 root 2. And if this is x, this side will also be x because this is square. So let's blow it out. So this is a rectangle. This is 20 root 2. This is x, this is x. So we know from Pythagoras, hypotenuse square is equal to the opposite square plus the adjacent squared. This guy here is 20 root 2 all squared is equal to x squared plus x squared. 20 squared is 400 times root 2 squared is 2. So this is like x squared plus x squared is 2x squared. So if I divide both sides by 2, our x squared is equal to 400. So if I take the square root of both sides, our x will be equal to square root of 400, which is equal to 20 centimeters. So our x is 20 centimeters. That means each of the sides is 20 centimeters. So the area of the square, which is the length times the width, is 20 times 20, which is 400 centimeters squared. And then the perimeter, which is 4 times the length, or any of the length of any of the sides, that will be 4 times x, and x is 20, so that will be 80 centimeters. So the area is 400 centimeters square and the perimeter is 80 centimeters. Let's see if we're correct. Great. Example 9 says that the perimeter of rectangular lawn is 24 meters. If the area of the lawn is 35 meters square, how wide is the lawn? Remember, the width is always a smaller distance. Let's solve this together. Perimeter of a rectangle said is 2 open brackets L plus W, and we said this is equal to 24. And the area of rectangle we said is length times width, and this is equal to 35 meters square. So this is 24 meters. Great. So from this we know that I'll just say this is my equation 1, my equation 2. So from equation 1 I can say L is equal to 35 over W, which will be my equation 3. And I substitute the equation 3 into which of the two equations? Okay, so I said from 1. Actually, I actually meant from 2. From equation 2. So I'll substitute equation 3 in equation 1. The one I did not pick at the beginning. So that will be 2 open brackets 35 over W plus W is equal to 24. And I can divide both sides by 2. This will give me 35 over W plus W is equal to 12. So LCM, this W1, this 35 plus W1, that's W times W, that will give me W squared is equal to 12. So that will be 35 plus W squared is equal to 12W if I cross multiply. So that will be W squared, let me take like terms, minus 12W plus 35 is equal to 0. I just rearranged it. So this 35W squared. What are two things that I can multiply? That will give me 35W squared, and if I had it, it will give me minus 12W. Basically, that is minus 7W and minus 5W. So if I substitute, that will be W squared minus 7W minus 5W plus 35 is equal to 0. And if I group from this first, so what is common? W is common. W squared divided by W give me W. Minus 7W divided by W give me minus 7. What is common in these two? Minus 5. Minus 5. So minus 5W divided by minus 5 give me W. Plus 35 divided by minus 5 give me minus 7 is equal to 0. Since I have the same thing here and the same thing here, then I'm good. So if I correct like terms, that will be W minus 5, W minus 7 is equal to 0. So W minus 5 is equal to 0, or W minus 7 is equal to 0. So our W here is 5 meters, or W here is 7 meters, but we know that we're told to find the width. The width is always a smaller distance, right? We've established that. So therefore our W, or the width, is equal to 5 meters, since it is the smaller of the two. If it was a theory question, I would advise that you actually state the reason why I'm picking 5 meters, just like I'm doing. Since you can just say, since the length is always greater than the width. Let's see if the answer is correct. Example 10 now says that the below diagram is a rectangle. If the perimeter is 36 meters, find the area of the rectangle. I'm sure you can be able to solve this by yourself. So pause the video and try it out by yourself. Welcome back. Let's look at it together. So we know that perimeter of rectangle is 2L plus W. So that would be 2 open brackets 2x plus 5 plus, and put this in brackets, plus x plus 1. So this is equal to 36. So 2 open brackets, I can open the brackets and say 2x plus 5 plus would give me the same 2 plus x plus 1. I did it because in case it was minus would change the sign of this plus 1. So you have to be careful. So that would be 2 open brackets 2x plus x, that would be 3x plus 5 plus 1, that would be plus 6, is equal to 36. 2 times 3x is 6x, 2 times 6 is 12, is equal to 36. So collecting like this, that would be 6x is equal to 36 minus 12, and 6x is equal to 24. If I divide both sides by 6, my x is equal to 4. So if my x is equal to 4, then that means the length will be equal to 2x plus 5, which will be equal to 2 open brackets 4 plus 5, that is 8 plus 5, which is 13 meters, and then my width is x plus 1, which is 4 plus 1, which is equal to 5 meters. So my area is length times width, which is 13 times 5, which is 65 meter square. So these are answers to this particular question. Let's see if we're correct. Great. Example 11 answers that we should find the dimension of a rectangle of greatest area which has a fixed perimeter P. This is from JAMB 2001. You know, we said already that the greatest area of a rectangle is taken from a square. Really. So that's why you can say this, let's say square, 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 square. Now, if the square has been determined to give us the greatest area, and then they said it has a fixed perimeter of P, how do we find perimeter of a square? We say perimeter of a square is equal to 4a, right? So the perimeter is P, and then the side is A. I can find the side by dividing both sides by 4 and saying that each of the sides of the square is P over 4. So answer is basically just D staring at us at our face. Once you know that it is a square, because the square that will give you the greatest area, like we said, and they said it's also a fixed perimeter. If the perimeter was variable, that is a different case, but the perimeter is fixed. Just divide whatever perimeter they give you by 4, and that will give you your answer, which would be option D. Great. So with this, we've come to the end of this particular question on area of a rectangle and perimeter of a rectangle, and we looked at the special case of square. I want you to look at JAMB past question, wire past question, any past question you can see in your hands, and solve as many questions as you can on this. If you have any question or you need any clarification, feel free to drop a comment. I'll respond to all comments. If you know me, I respond to all comments almost as soon as it drops. I can't promise I'll do that, but I'll respond to it as soon as I can. I'll see you guys in the next video. Bye for now.